Okay, today is basically about what is electricity. Electricity is the flow of electrons. It can be similar to the flow of water. It has a pressure and a volume, like a water pick that you would use on your teeth has high pressure but low volume. The water coming out of a garden hose has medium volume, low pressure. Coming out of a fire hose, you have high pressure and high volume. The same is true with electricity. The pressure, though, is not measured in pounds per square inch. It is measured in voltage, volts. And we typically use the symbol V for that, capital V. Small v is reserved for velocity. But that's the units used for that. That is also called by some the potential difference. It is the difference in electrical potential between 2 points, or the pressure difference between 2 points in a circuit, or on a the two terminals on a battery. The volume of electron flow is measured in amps. The big A. A small amount of current is used for things like LEDs, that sort of thing, whereas a large amount of current would be used for driving an electric vehicle, for example. It is these two characteristics of electricity that are typically measured. Now, the power is measured by getting the voltage times the amperage. And that's in watts. So the equation for power is VI, because the variable used for voltage and amperage are typically V and I. So P equals VI. So you have say you have a 100-watt light bulb in a 100-volt wall outlet, although it's typically 110 volts. just for the sake of easy math, let's say call it 100 volt wall outlet. Power is 100 watts. Voltage is 100 volts. The amps used, the current being used would be 1 amp. Whereas a 25 watt LED light would only use 1/4 of an amp. So you can determine the characteristics of the circuit by just plugging in the numbers into simple equations like this. Now, electricity comes in 2 different flavors. Batteries provide direct current. Direct current is a constant voltage. Now, there are other sources of constant voltage as well, direct current, like the USB port on your computers or your charging blocks that you charge your phone with, that sort of thing. That's DC as well. For USB, it's 5 volts. For a AAA battery, it's 1.5 volts. For a car battery, it's 12 volts. For an HEV battery, it's 6 volts typically. It just varies depending on the source, but it's a constant level, a constant voltage relative to ground. Voltage is measured as a difference between the positive charge and ground, positive and negative. So alternating current is not a constant voltage. The voltage fluctuates, typically above and below ground. So if this were ground, DC would be a constant voltage above ground. Whereas an alternating current is typically a sine wave above and below ground. So the reason for that is that's what the alternating current is, what comes off of generators that have a rotating magnet inside a coil of wire, and it's easier to transmit over long distances. Direct current doesn't do well over long distances. But alternating current, as you can imagine, measuring the voltage depends on where you measure from or when you measure it. So the peak to peak voltage is one way to measure it. Then there's also, but there's more commonly used is what's called RMS voltage. The RMS voltage, or root mean squared, I should write that down. The root mean squared voltage is the level of voltage where it's more reflective of the work that the electricity can do. The root mean squared voltage, so VRMS equals 0.707 of the voltage peak to peak. Getting into the why of that is beyond the scope of this class. Just accept that it's about, approximately, let me put that, approximately 0.707 of the peak-to-peak voltage. So when you have a 110 watt outlet, like over here on the wall, that's the RMS voltage. That's the voltage that you can get effective work out of. The RMS voltage is right around here. As you can see, the voltage spends very little time beyond that range. So the amount of effective work is more in line with the RMS range of voltage. Now, another little quirk about alternating current, AC current, is phase is a factor. So say you have ground and you have one lead with that voltage, and then this another lead with this voltage. Now, if you measure the voltage between the two leads other than ground, you have twice the voltage, because you're going to be measuring from peak to peak, from here to here, rather than here to there. So this is where you get a 220 circuit in a house. You know, where you plug in an electric dryer, it has 3 prongs. One is ground, one is one phase, and one is the other phase. And the 2 hot leads are 220 volts apart. And let's see here, I didn't have it written in my notes how to calculate the power when there's a phase difference. What is it? I can't remember if it's sine or cosine theta of the phase difference of the angle, but I'll have it for you another time. This will give rise to multi-phased electrical circuits. That's why, like the 2-prong outlet is 110, and the 3-prong outlet for a electric dryer or AC unit or whatever is a 220 volt. So you get that phase, different phases of potential difference. All right, let's see here. Now, this the DC and the AC give rise to two different types of signals. AC, since we're discussing that, is an analog signal. Voltage fluctuates. Analog signals are things like audio recordings, the light you see in a on the screen of a movie in a movie theater. The light levels change to give the illusion of movement. Now everything seems to be digitized nowadays to make it digital signals. Digital signals are only 2 voltages. High and low. Not on or off. Do not make that mistake. It is not on or off. It is high or low. It is either power or ground. If it's not connected to anything, that is a separate state, a third state, which is not measurable by electrical devices, but is handy in some computer systems. The tri-stated or high impedance state, or high Z. Those are off. So if you think about it logically, you have a battery, you can have a wire connected to the power, you can have a wire connected to the ground, or wire connected to neither one. Now, digital signals come in a wide variety of forms. USB communication is digital. A sequence of pulses to indicate binary numbers being sent across a wire. Digital video is done with ones and zeros as well. 2 voltages are, these are often referred to as 1 and 0 logically when you get into, or if you've been in digital logic already. You know that high state is 1, low state is 0, or ground is 0. But the tri-stated thing is off and should not be mistaken as it being a 0. Let's see here. Well, I told you it was going to be a brief lecture. That's basically the characteristics of electricity. Any questions that you might have? More examples? Or I'm sorry? No, digital signals are direct current. Yes, it'll fluctuate. It'll go from the direct current positive or direct current ground, but it's not. There's very little time in between. I'm sorry? It's like an either or type of thing. Yes, it's either or. Yeah. Analog signals are alternating current, typically. That's what you get off of a microphone into a speaker. Yeah. No, I'm writing one. So there might be in a couple of years. But not, there's no textbook. I just put together various topics for the, to introduce you into the program here. Yeah. Yes, that's what I said on the previous slide. Yeah, voltage times amperage. Yes, current is measured in amps. I'm sorry if I did not make that clear. But yeah, power in watts is voltage times amps. A little note about electrical storage. Batteries are rated as amp hours, in amp hours. It's like, say, 3 amp hours. It's say it's a battery block for a USB. So that'd be at 5 volts. That would mean it could deliver 5 volts at 1 amp for 3 hours. As opposed to, or 1.5 amps for 6 hours. It depends on the current drain. Yes. Oh, a tri-state is the non-connection. Like I said, like I used the example of a battery. You say you have a battery, you have the wire connected to the ground, that's low. Wire connected to the positive pole, that's high. Not connected to either one, that's the tri-state. High impedance, high Z, whatever you want to call it, that's the third state. No connection at all. But yeah. Any other questions? No? All right. Have a wonderful day, and I will see you on Monday.